Hello class and welcome to lesson 3.2 Organized Counting. Today's expectation involved doing counting problems that involve either the additive and the multiplicative counting principles. I don't know if you have this dilemma in the morning when you get dressed, but trying to pick out an outfit for some people can get frustrating. So let's take a look at example 1 and see if we can help discuss all these options on getting dressed. Okay, number 1. You have 2 pairs of pants, black and gray, 3 shirts, white, black, and green, and 2 pairs of shoes, runners, and dress. Use a tree diagram to illustrate the different possible outfits. Okay, so again, with our space to do a tree diagram, we're going to start in the middle. Let's start with pants first, folks. So for our pants, we're going to either have black or gray. Okay, and that's our pants. So just put a little title there for pants. Okay, then we take a look at our next option is shirts. Okay, so we have 3 different types of shirts, so we can go 1, 2, 3, 1, 2, 3. And our shirts are going to be white, black, and green. White, black, and green. Okay, and that's for our shirts. Okay, now we'll take a look at the last option, which is our shoes. Okay, so we have 2 different types of shoes. So 1, 2 for each. Okay, and then we'll title those shoes. Okay, and so we've got runners and dress. I'll go R and D. Runners, dress, runners, dress, runners, dress, runners, dress, runners, and dress. All right, so now we want to list all the total outcomes. So we write a top subtitle, outcomes. And again, like last day, we start from the very top. I'll do the first one to show you what it looks like. So we're going to go black pants, white shirt, runners. So that's going to be BWR. Okay, then we're going to go black, white with the dress, shoes. Then we're going to go black, black runners, black, black dress. Then we're going to go black, green runners, black, green dress. So that's the top part is done there. And then we're going to do the bottom part here. So we're going to start with the gray. So we're going to go gray, white runners, gray, white dress, gray, black runners, gray, black dress, gray, green runners, and gray, green dress. Whew. That was quite a list, but hopefully we have enough room to fit in our sample space. Let's total them up, and hopefully, folks, you should have 12 when you are done. So number in our sample space, that's what this coding stands for right here, is 12. So there's 12 possible outcomes. Okay. All right. So it says here that this question involves, choosing one option and other options or stages with separate choices. Okay. So it's the and principle we're looking at here. Okay. And so we use what's called the fundamental or the multiplicative counting principle. And I believe I discussed this last lesson a little bit. So if we're looking for number of options and it doesn't ask you to do, number of outcomes, which are options of outfits here, guys. It doesn't ask you to do a tree diagram, then you can say, okay, how many options do we have with the pants? So it's going to be number of pants outcomes. Okay, and then you're going to times that by the shirt outcomes or options. And then you're going to times that by the shoe options, right? Or outcomes. Okay, so if we go to fill this in, number of pants we have are 2, times number of shirts we have are 3, times number of shoes we have are 2. So 2 times 3 is 6 times 2 equals 12 outcomes or outfits if you want to take a look at it in this case. All right, so that's called the fundamental multiplicative principle. Please make sure, folks, that you understand that this is and. Okay, so let's just put a box around this because it's important. And then you want to somehow make sure you've got it marked off that this is and. Okay, because it includes all options. Okay, because we've got shoes and shirts and pants. Okay, all right. Let's take a look at the opposite situation. Okay, sometimes we want to have one action or another. So this is called the rule of sum, or what we call the additive principle. Okay, and this is where the two events cannot both occur. Okay, so we're going to put a box around this one and make sure that we highlight or know that this is your or situation. Okay. And here's an example down here below. So it says, how many ways can you roll a 7 or an 8 with 2 die? Okay. Well, if you take 2 die, if you have them at home, grab them. Okay. How many different ways can we roll a 7? Okay, so a roll of 7. Well, if you have 2 die, you can say 1 and 6. The first die is 1, the second die is 6. Or you can have the opposite, the first die being 6 and the second die being 1. Okay, so you've got 2, 5 or 5, 2. Okay, 3, 4 or 4, 3. So we have a total for a roll of 7 of 6 possible ways we can roll a 7, right? Now, how do we roll an 8? So a roll of 8 on a die. Let's think of our combinations. So 2 and 6 and 6 and 2. Please, folks, understand you can't do 7 and 1 here. If you're not sure about how to die, it's only has 6 sides, so make sure you know that. Okay? So 3 and 5 or 5 and 3. And then 4, 4, you can only be done once because both have to be 4. Okay? So there are 5 ways here. Okay? So number of ways to answer this question, number of ways to roll 7 or 8 equals 6 plus 5, which equals 11. So notice how we added here, okay, because of an or. This is one option or the other. So for an or, you add. Okay, if we go back quickly for when it's an and, so notice this question, we have 2 pairs of pants and 2 pairs of shoes and 3 shirts. Okay, the and tells us to multiply. So and means to multiply, or means to add. Okay, all right. Let's take a look at a tricky example, and this one is not going to be something that's going to be done quickly, and I want you to try to see if you can figure this one out as we go along. Okay, so third one. And it says a quiz has 3 multiple choice questions. Each have 5 possible outcomes. Okay, so I've got question 1. You could answer A, B, C, D, or E. I have question 2. And you could answer A, B, C, D, or E. And I have a third question, 3. And I could answer A, B, C, D, or E. Okay, so 3 questions, okay, and we're going to get visual about this, okay? Now, how many possible ways could you answer? Okay, so this is the different possible ways you could answer. Okay, so for the first one, number of ways is going to equal, okay, how many different ways you could answer question 1 times, because it's an additive, because it's a multiplicative and you're going to multiply, okay? How many different ways you could answer question 2 times how many ways you could answer question 3, okay? Well, for each question, folks, you could answer 5 possible ways, so 5 times 5 times 5, because each option has an A, B, C, D, or E. So you could pick one of 5 different ways to answer each question. Okay, we multiply those together. We know that it's 125 different ways that you could answer this multiple choice question. Okay, so that wasn't so bad. The second one, how many ways are there to get all three correct? Okay, so number of ways, another way to say all three correct is to get 100%, right? So 100% means you got them all, right? So number of ways to get all three correct is that you take a look. What's happening at question 1 times what's happening at question 2 times what's happening at question 3. Okay? Well, for question A, folks, how many right answers are there? There's only one correct answer. Same with question 2. And same with question 3. And I'll quickly tell you, folks, that when I did my first year bio at university, I think it was 2 hours with 200 multiple choice questions, and they were tricky. Okay? So the probability of anybody doing successful, you got to really know your stuff. Okay? So 1 times 1 times 1. So there's only one possible way that you could get 100%, because you have to get question 1 right, to get question 2 right, and question 3 right. Okay? Everybody okay with that? Hopefully that's okay. Here's where we get into some difficulty. And this is where it takes a while. Make sure you have an organized solution. You may solve it a little differently than I do. Okay, and I'll show you 2 different methods. Okay, so C, how many ways are there to get at least 1 wrong? Okay. Okay, and I'm going to show you that there's 2 different ways we can solve this. We can solve it using the direct method or the indirect method, and I'll explain each as I go. So there's 2 ways that we're going to solve, 2 different methods. Okay, so the first one is going to be the direct method. Sometimes you guys will always use the direct method. Sometimes you'll find that, hey, the indirect method is the easier method. Okay, which means you're just solving for the opposite and then subtracting. Okay, all right. All right, so let's try to understand the question. Okay, the question says that we have to get at least 1 wrong. So how many? You could have at least 1 wrong, you could have at least 2 wrong, or you could have what? All 3 wrong. So make sure everybody realizes that, hey, we have 3 separate cases here. Okay, so we have 1 wrong, 2 wrong, and all 3 wrong. Okay, so when we have separate cases, we're going to learn that we're going to add the individual cases up. Okay, and we'll discuss this by doing a little bit of visual diagram. Okay, so let's take a look at doing the case 1 first, which is 1 wrong. Okay, so how do we figure out how we could do that? Okay, so if we have 1 wrong, okay, let's just take a look. We got question 1 times question 2 times question 3. Okay, so say you got the first one wrong. How many different ways can you get that wrong? That's 4 times. Okay, okay, and then if you got question 2 and question 3 right, then there's only 1 way to get it right. Okay, all right, okay. So that's 4 possible ways for that one. But that's only if you get question 1 wrong. Okay? What if we had question 2 wrong this time and we got the question 1 and 3 right? Okay? So there's only 1 way to get it right, 4 ways to get it wrong. Okay? So if you got, say you got question 2 wrong but 1 and 3 right, there's 4 possible ways that could happen. Or you could get question 1 and 2 correct, and the third one you could get wrong. Again, there's only 1 way to get it correct, or 4 ways to get it wrong. Okay, so now notice that we've taken a look at, with 1 wrong, we decided for the first one, question 1 was wrong, for the second one, question 2 was wrong, and for the third one, question 3 was wrong. Okay, so let's total those up, folks. That gives us, we add them up. Okay, so that gives us 12 ways here. Okay, so what does that mean? Therefore, there's 12 different ways to get one wrong. Okay, everybody okay with that? All right, let's set the same situation up, but what happens when we get 2 wrong? Okay, so I'll do the same thing. Question 1, question 2, and question 3. Okay, so let's say I get the first question right, but question 2 and 3 wrong. Okay, again, how many ways can you get a question right? Only once. How many ways can you get it wrong? 4. Okay, so 4 times 4 this time is 16 times 1, right, guys? Good with that? Okay, that's one example. Or we still have the other option where, let's say we had the second question right, but first one and the third one wrong. So it's going to be 4 times 1 times 4, that equals 16. And again, we can say, or, what if we had the third question right and the first 2 wrong? Okay, so it's going to be 4 times 4 times 1, and that equals 16. So total those 3 options up, and you add them. Okay, because they're ORs, right? So add because they're ORs. All right. So what does that tell us? Therefore, we have 48 ways to get 2 wrong questions. Doing okay? All right. We still have to do case 3, which is all 3 wrong. Okay, so let's do that now. 3, or I'll put all of them wrong. All right. Question 1 times question 2 times question 3. And this one's kind of the easiest ones. So, if I got all 3 wrong, folks, how many different ways is it to get a question wrong? 4 different ways. And we have all 3 of them wrong. So 4 times 4 times 4 equals 64. Okay, so therefore, there's 64 ways to get all 3 wrong. All right, so we're almost done. Now we have to total everything up. So total number of ways equals case 1. That's with 1 wrong. And you're going to add, my fault, let me change that, plus case 2, which is getting 2 wrong, plus case 3, which is getting all 3 wrong. Okay, so when we had 1 wrong, it was 12, plus case 2, when we got 48 wrong, plus case 3, we got all 3 wrong, that was 64. So you add them all together, equals 24. Okay, so that nice therefore statement. So therefore, there's 124 ways to get at least 1 wrong question. Okay, so folks, that was the direct method where we found the answers to each of them. Now I'm going to show you the opposite and the indirect method. And some of you are going to like this and some of you are not. And that's okay. So I'm just going to put it below here. Okay, so method 2, indirect method. And usually it's the opposite strategy. So instead of calculating exactly what they were looking for, we're going to do the opposite. Okay? So for example, what is the opposite of getting at least 1 wrong? Meaning what? The opposite of that means that they get what? All 3 correct. Okay? So this indirect method, it's going to seem shorter because we did a lot of the work, but the number of ways equals the total possible ways, right? Total possible number of ways. Okay? Subtract the case that's opposite of what the question said. Oh boy. Opposite. Okay? So that means the opposite case means instead of having at least one wrong, the opposite is getting all 3 correct. And on your test, folks, I will ask you specifically to use an indirect or direct method, or I just say solve and you get to choose which method you like. Okay? So, total number of possible ways we figured out in A, which was 125. Subtract the case where you get all 3 correct. We actually did that in B, which was 1. So that gives you 124 ways. So again, you'd put a therefore statement on there. Therefore, 124 ways to get at least 1 wrong. Okay? It's the opposite. So remember, if you're doing indirect, you use the opposite case. Okay? Sometimes that works, sometimes it doesn't. All right, here's your homework for today, gang. Page 229, numbers 1 to 6 and 8 to 12. Have a great day, and of course, come see me if you need any help. Ciao.